In this lesson, we're going to look at what happens when you multiply a vector by a number. Not by another vector, but a scalar quantity, i.e. 2 or 6 or a half or whatever it is that you want to multiply the vector by. So I've set up an example here in terms of trolleys. So if we've got a force here, F, pushing the trolley of 10 kilograms, if you double the mass of the trolley to 20, for example, here, what you need to do is double the force to move it. So that's in effect doubling the vector quantity here to move the trolley. Now you can see that 2F here has the same direction as F, but has twice its magnitude, twice the size of it, because the length here is 2 times the size of this one. And obviously the size of the force would need to be doubled to push the trolleys. Now in general, if we've got a vector here, xy, then to multiply it by a number, a scalar quantity, then you multiply the components of the vector. So you multiply x, the top one, by the number, and also y. Also, the vector is parallel to the original vector when you multiply it by a scalar. So if we look at this idea here, and we draw and label representatives of the vectors below, if p is negative 1, 4, then if we start here, now negative 1 would be back 1, and let's start here actually. So negative 1 would be back 1 and up 4, 2, 3, 4. So p would look like that. So if we were to draw 2p, then if we start with a point here, instead of going backwards 1, we'd go backwards 2, and then instead of up 4, up 8. 1, 2, 3, 4, 5, 6, 7, 8. So you can see the vector there is parallel to the original p, but it's double the size of it. 3p would just be 3 times the size of it. 3 over 2 would be 1.5. We'll look at this last example, negative 2p. So let's start here. So negative 2, if I multiply the negative 1 by negative 2, I get positive 2. So we go along this way, and instead of going up 4, so I'm going to multiply the 4 by the negative 2, I'm going to go negative 8, so down 8. 2, 3, 4, 5, 6, 7, 8. And this is my starting point, and this is my finishing point. So you can see that the vector has swapped directions because it's been multiplied by a negative. It's exactly the same size, and it's parallel, but it goes in opposite direction to the 2p here.